The topic that we are going to discuss today is complex values. Before we actually go into complex values, let's talk about types of numbers. Well, remember in elementary school, you learned about types of real numbers, right? A real number can be an integer, it can be a whole number, right? And it can be rational or irrational as well. Well, so technically, we can group them into, well, the real numbers are grouped into two major types, rational numbers and irrational numbers. Basically, rational numbers include all the numbers such as integers, whole numbers. Any number that can be written as a fraction can be grouped as a rational number, and the numbers cannot be given as a fraction are irrational numbers. So, for example, an integer 1, 1 is technically 1 over 1 as well, right? So that's a rational number. Square root of 4 equals to 2, so it's rational. 0.2 can be given as 2 over 10, hence 1 over 5. So it's rational as well. And repeating decimals, though it doesn't end, right? If the digit repeats, then it can also be given as a fraction. So these are all rational values, integers or decimals that has an end, or a decimal with repeating ends. So what are irrational numbers then? Well, irrational numbers cannot be written as a fraction. So usually numbers like pi, where there is no end, right? And there's no pattern here. It doesn't repeat. That can never be written as a fraction. And such as square root of 3. These are all irrational numbers. So again, rational numbers can be written as a fraction. Irrational cannot be written as a fraction. Now, so these are real numbers, guys. Irrational or rational, they are both real. However, for special cases, we do get something called imaginary numbers. Imaginary, as it suggests, is not real, right? So we can't really show that value on a regular xy plane. For example, remember the equation y equals to x squared, where there were 0, right? Over here at the vertex, right? This value had a 0 because it actually did go past through the x-axis at 0. But if you consider y equals to x squared plus 1, where it's actually pushed, you have to push this up by 1 unit, right? Hence, there are no zeros. So technically, there are no real zeros here, but if you still try to look for the 0 by letting y is equal to 0, you will see that your x squared should equal -1. Hence, your x should equal, well, positive or negative, square root of -1, which, well, usually for algebra 2, which we just code it as no solution. But starting from pre-calculus, we actually have to continue this as a proper solution by converting square root of -1 as I, and that, guys, is an imaginary number technically. An imaginary number basically is a way for us to write square root of a negative number using I. So basically, whenever you see I in your notation, you will know that equation or that number is a mix of imaginary and real, or just imaginary. Well, those are numbers that we call as complex values. So such as, how you can just write 2 plus I, or you can just write -2I, or 3 minus 5I, for instance. These are all just complex values because this has like real number part with imaginary number. Hence, it's complex, right? It's quite simple actually. So it's square root of -1 that is given as I. So, well, you need to understand what happens when you square it, cube it, or to, well, any power to it, right? So, for example, if you do square I, since you're squaring square root of -1, the outcome, well, is equal to, what is it? the square root and square cancels each other out, hence just -1. If you cube that, it's technically multiplying I by I squared, right? Where I squared equal to -1. So you will be getting a negative I. So if you do I to the 4th power, you're just squaring -1, right? Hence, it becomes +1. And the interesting thing is that if you continue this by multiplying this by another I, right? So if you go for the I to the 5th power, it's back to I, because multiplying 1 by I equals to I. And again, if you do that again by another I, hence I to the 6th, it's -1. So as you can see, the I to the 1 is I itself. I squared equals to -1. I cubed I to the 4th, 1, back to I for I to the 5th, then -1. So as you can see, the values, right, for the power does repeat after 4 terms. It goes from I, -1, -I, +1, then all the way back to I. So technically, if you're looking for I to the any power, right? What you do is, since you know that this is repeating after every 4 terms, you just need to figure out, right, what your remainder is when n is divided by 4, okay? Get the remainder, all right? Not the quotient, but the remainder. Get the remainder, and remember this, if your remainder equals to 1, well, since you're dividing n by 4, what kind of remainders will you get? You will get a remainder of 1 or 2 or 3, or you won't get a remainder at all. And as you can see, any multiples of 4s will have no remainder. Hence, if you have a remainder of nothing, it means that your I to the n, right, will be equal to 1. If your remainder equals to 1, then it's just simply your I to the n will equal I. If it's a remainder of 2, then -1. Remainder of 3, then -I. All right? So you must just simply remember how this is played, right? By the remainder. Get the remainder, and remember, remainder 1 means I. Remainder 2 means -1. 3, -I. No remainder means 1. So as a quick example, so if you were to evaluate I to the 99th power plus I to the 100th, right? Plus I to the, 101 and 102. Now, this is divisible by 4, which means there will be no remainder here. Hence, that should equal 1. And what about the next one? This has a remainder of 1. Hence, this equals to I. What about this? That equals to, -1, isn't it? Because this will leave a remainder of 2. And back to 99, that has a remainder of 3. Remainder 3 meant -I. So when they ask you to find the sum of these 4 powers, they're basically telling you to find the sum of I, -I, 1, +I, and -1. Hence, the sum should equal 0. The answer to this would equal 0. All right? So that's how you find the power of I, by using the remainder when the exponent is divided by 4. Okay, so far so good. You know how numbers are divided into real and imaginary. So imaginary is not real because technically it's, you know that you can't put a negative number inside of the square root. Since we can't, we have to use another notation, another term, I, that, replaces that negative part inside of the square root technically. And a complex value simply means that, there are some imaginary part to the number. All right, now let's continue talking about how we can use I. Well, the I's can be used for, many things, especially can be used for determining the zeros of polynomial equations. remember how I told you that if x squared plus 1 is given as the function, the zeros are positive or negative I, right? We can't graph it because it's not real. Meaning there will be no real zeros, right? However, it clearly shows that it has no real zeros, but it has two imaginary zeros. For instance, remember for polynomial classes, I told you that the degree of the function, right? The degree of the function must, right, be equal to the sum of like the entire numbers, right? Numbers of zeros, whether the zeros are real, right? Or imaginary. So real zeros with imaginary zeros all together, the total number should equal to the degree. So sometimes you have to look for the numbers of real zeros and imaginary zeros of a polynomial function. You just need to remember how the degree of the function is related to the numbers, right? The number for zeros. So anyways, the numbers, right? For example, say that you have square root of -4. Just for people who has never done i's before, let me just show you how you can convert numbers with negative values inside into I form. So technically, what you do is you have to make this into a product of +4 and -1, right? Hence, it's simply this being I. So it's square root of 4i, hence 2i. It's quite simple actually. So you first separate it. So basically, you separate them, right, by putting I, right? That will replace the -1 part. And whatever you do afterwards is like the regular thing that you do with any square roots. Just simplify it. Since this is 9 times 3, the 9 comes out as 3, hence, right? Just like this. It's quite simple. So that's how you write any negative radicals into I form. Well, square root, of a negative value can be given as something I. And another thing for complex values, it is related to the polynomials 0 a lot as well. But also, the complex value itself is actually quite important. You will be asked to find the sum of two different complex values, and or for instance, you have to know how to graph a complex values as well, which sounds a bit strange because I just told you that imaginary numbers are not real, hence it can't be shown on a graph. But when the problem talks about the graph of a complex value, right? Actually, they are not talking about the actual x and y axis. What they do is we create, right? What we do is we create a plane, right? Using the y-axis as the imaginary axis, x as the real axis, as in your A, right? The part without the I will be representing the real, and B, right? In front of the number multiplied to I, right? Will be representing the imaginary component. So technically, graphing a complex value is basically plotting the point A, B on a complex plane. Okay? So if you're to graph 2 minus 3i, right? You're simply marking a point at 2, -3. So somewhere down here, right? 2, -3. There goes your point. So you just remember how a complex value can be plotted as a point on a plane because we are using that plane, right? Not for the x and y, but using them as real and imaginary values of a complex value. Okay, so let's just have a quick summary. So I is square root of -1. In order to evaluate this, right, we have to look for the remainder, right? Find the remainder. And since there are 4 types of remainder, right? 1, 2, 3, and none. If it equals to 1, then you're supposed to get just I itself. If it's 2, then you get -1, -I. For 3, remainder of 3, and no remainder means 1. Your power becomes this, or that, okay, depending on the remainder. And for complex values, well, we know how we can convert any square root of negative value in the I form. And we also know how we can graph it using the A and B as the, well, technically consider A and B as X and Y, all right, if you're confused. Just get the values and just plot it. And, well, it's also related to looking for the imaginary zeros of polynomial functions, right? So, you know, just like remember how, you know, this can be graphed or how to evaluate this as actually, those are quite important. All right, so let's talk about other things that you need to look for. Well, the most of the problems on complex values do involve evaluating the power, dealing with the graphs, right? But also, you need to find the sum or the difference or the product, right, etc., etc. Well, the operations with complex values are actually quite simple if you think about it. You know the term like, you know, like the like term, you know what it means to have like terms within the equation. It means that basically they share the same, well, variables, right? Well, with complex values, we can actually separate each complex value as real number and imaginary number. So, for example, the 2 and 1 are the two real numbers here, and negative 3 and positive 4 are the two imaginary number part. So anyways, starting off with question A, you're to find IP. Basically, simply means to multiply I by P, which is 1 plus 4I. So, well, you get positive I, right? And you will be getting 4I squared. But here, you know that I squared equals to negative 1. Hence, you have to write negative 4 plus 1. Well, we always write the real number first, so you might want to switch the values around. So this is like the one thing that you have to watch out for. People do easily forget that when I squared, negative 1 comes up, because usually we think that whenever the number is squared, you will be getting something positive, right? But not for i's. For i's, you will be getting a negative outcome. All right, now, subtraction. All right, now, so for subtraction, this is when we have to actually separate the real number part and imaginary number part, because when it comes to adding or subtracting, we are to subtract or add the, well, real numbers with each other and imaginaries with each other. So technically, what you're doing here is, okay, I'll just write real here. Real as in 2 minus 1, and imaginary as in negative 3, right? Minus 4, right? I. That's what we are doing. We are actually doing the real number subtraction with another real number, imaginary by another imaginary. Just keep them separated. Hence, the outcome for this will be 1, right, with negative 7i. Actually, you don't even have to separate them. Once you get used to it, it's really simple. Well, 2 minus 1, which is 1, right? Negative 3i minus 4i, negative 7. So, the answer should just like pop out like that. Okay, 2n plus 3n. 2n means to just multiply your n by 2. It's just simply 2 times 2 minus 3i. 3p means 3 times 1 plus 4i. So what you're getting is 4 minus 6i plus 3 plus 12i. Again, you're dealing with real by real, imaginary with another imaginary. So you'll be getting 7 and positive 6i, right? N times p. Well, I mean, they are, though these are complex, you can just think of it as two binomial, being multiplied together. You need to do foiling, foiling, right? Having to multiply each term from one bracket, with every single term on the other bracket. So 2 times 1, 2, plus, 2 times 4i, 8i, negative 3i, And finally, okay, this is the important part, guys. Negative 3 times 4 is negative 12, but with an I squared, right? Since I squared is negative again, double negative, hence positive 12. If you learn to do this a bit of calculation in your head, you can save some time, but if you are not very good at it, you may just write negative 12 I squared first and then, convert that into plus 12 later. It's not a big deal. All right, now, squaring them, again, it just means to square it. So you can do 2 minus 3i times 2 minus 3i, or, you know the rule, when a minus b squared is squared, you do a squared minus 2ab plus b squared, right? So you'll be getting 4 minus 12i plus, well, watch it, you will be getting plus 9i squared, where I squared is negative again, so you'll be getting negative 9. So negative 5 minus 12i is what you get as n squared. All right, now, last question, 1 over n. Well, guys, this is slightly different because this is not because it's a complex value. It's actually because I itself is a square root. Remember something that you probably learned from Algebra 1, how we cannot keep radicals as denominator. Hence, we have to rationalize it. Remember how you did it? Like, for example, if you have rationalizing, basically meant making the radical denominator into something non-radical. Like, for example, you will have to multiply the both numerator and denominator by the given denominator, hence that the outcome no longer has radical in it, right? What did you do when you had something a little bit more complicated than just simple square root of a number? What if you have 2 minus 3i? What do? You have to multiply still the numerator and denominator by something. And that something is the conjugate, right? Conjugate means what? The conjugate means the changing the sign, right, in front of the radical part. So technically, well, 2 stays, but negative 3i becomes positive 3i. That's the conjugate, and by multiplying this by its conjugate, guys, the reason why we are doing it is to use this, actually. You know this, right? The product of difference, basically the difference of squares. I mean, if you have a squared minus b squared, it's the same thing as the sum and the difference being multiplied. So if you multiply 2 minus 3i by 2 plus 3i, you will be getting 4 minus 9i squared. Hence, you will be getting plus 9. Okay? And as for the numerator, it still is just that because it was 1 over. Hence, as you can see, now our denominator is a simple non-radical number. So now this is, it's just perfect. Okay, now, before before you start panicking about having to do all this, right? Let me just tell you one thing. Any calculators, okay, I'm going to use TI for example because that's what most students do use. They do have an I, in their calculator. So technically, all of this, right, including having to rationalize it, is all doable with your calculator. So if you are taking the SAT subject test and if you are not very sure of your calculation, then you just simply do the entire thing with your calculator. All right, look for where your I is. For TI-84, it's like, at the bottom, of the calculator. All right, TI-89 has it too, obviously. By the way, though, when you do this, right, in your calculator, like, so you do type in 1 over parenthesis 2 minus 3i, right? You might see this as in 2 over 13 plus, like, 3 over 13i in decimal form. not in fraction form. So if you want to convert that into fraction, you just need to simply press math, and you have to just fractionize it, okay? Just enter on fractionize and then the answer, and then you will be getting the answer in fraction form. All right, so it's really simple, guys. If you panic in the middle of the test, you forget what to do in order to rationalize it, just simply plug the values into the calculator. It's really, really simple. So, you shouldn't get anything wrong on complex value operations, all right? It's all doable with your calculator. Okay, so is that all the thing that you need to know? Graphing, adding, subtracting, multiplying, and dividing? Well, no. There's just a few more, actually. Well, conjugate, I already told you, is simply changing the sign in front of I, right? In front of the square root. Okay, now, what is this? Inverse of. Whenever you have to look for the inverse of a number, you are actually looking for the reciprocal of the number, right? So if you have a number 2, inverse of that, right? Inverse is 1 over 2 simply. Complex value, okay, again, it's not a function, right? There's no x and y to be swapped. Inverse literally means to, to the number to the power of 1, which means 1 over, right? 2. So an inverse of a plus bi means a plus bi to the power of 1, which simply means bi. Again, if you were to look for the inverse of, say, if you're looking for the inverse of 3 minus 5i, right? You're looking for 1 over 3 minus 5i. And from this, what you have to do is you have to either, by hand, multiply everything by 3 plus 5i, rationalize it because, you can't keep I as denominator. And then, work this out, which is 9 plus 25, right? It's plus 25, guys, which equals to 34. Hence, you may look for this, or you can simply write this in your calculator. 2 options. Well, they're both simple, but, if you think that you're a bit clumsy for yourself, then, then I suggest that you do use your calculator. All right, anyways, and plotting a plus bi, how do we do that? We consider a and b as the coordinate, right? Hence, we have to just find the point and plot it. That's all. What about absolute value of a plus bi? Guys, absolute value of a number basically means that you are looking for the distance between a and the origin, right? It's the distance, basically. Absolute value means that you're looking for the distance. So what distance are we looking for? We are looking for this distance. Say you had negative 2, 3 as your point. If you're looking for absolute value of negative 2 plus 3i, it actually means that you are just simply looking for the distance between the point and the origin, hence this. How are you going to look for that? Again, well, you know how to look for the distance between 2 points, right? What do? We measure the vertical and horizontal distance between the 2 points because the 2 distances will create, right, some kind of right angle triangle. And well, since the coordinates were negative 2 and 3, 3 and 2 are the 2 legs, basically. And what we have to do is do simply, do Pythagorean theorem. So you'll be getting the distance as square root of 9 plus 4, hence root 13. So to generalize it, considering a and b as the distance for the 2 legs of a right angle triangle, absolute value of a plus bi is always equal to square root of a squared plus b squared. All right? Again, understand the concept, alongside with the formula so that you don't get confused or forget about it. Okay, so conjugate inverse and how to plot and how to find the absolute value of a complex value are the last things that you need to remember when it comes to complex values. All right, now let's do some examples now. All right, so absolute values. It's I think, having to find the absolute value of a complex value is actually quite important when it comes to SAT subject test. Of a single value, it's quite easy. Again, what you're doing is you're doing square root of 4 squared, right? Plus negative 3 squared, hence root 16 plus 9, which equals to 5. Oops, 5. Okay, now, what about this? What is that? It says find the absolute value of m minus 2q. So what should we do? Well, the PEMDAS rule, we always work with the parenthesis first, though it's not a parenthesis, but we should always go from inside then outside, right? So find out what m minus 2q is. We actually already practiced on subtracting with the previous examples, right? m minus 2q would equal 4 minus 3i minus 2q, which equals to negative 2 minus 4i, right? And how do we subtract them? We subtract the real number by real, imaginary by imaginary. So you'll be getting positive 6, right, with 1i, right? Negative 3 plus 4. So that, now, in order to find the absolute value for m minus 2q, you are doing absolute value of 6 plus I. So here, what you're doing is you're looking for the difference, and you will, get a single complex value again. Then you're simply doing square root of 6 squared plus 1 squared again, which should equal now 37. Square root of 37 is the answer to example B. And guys, please do remember that. This is more common, when it comes to math to exam. All right, now this too, I actually do enjoy doing this question. It's quite smart, actually. It says there is a point, and then the point lies in quadrant 2. And we have to find out where negative I times P should lie in. All right, so what is this talking about? Okay, so you're having some complex, value plane. So this is the real number axis, and that's the imaginary. And there is some random point P somewhere here, all right, in the second quadrant. So we need to figure out where negative I times P should lie in. Well, since this is the quadrant, right? If your point P initially was in second quadrant, it means that your real value for that complex, value is negative, where imaginary is positive. So here, you can actually use like some number of your choice, right? To let PS, as long as you keep your real negative, so we'll go for negative 3, and your imaginary positive, right? It's totally fine. So negative 3 plus 4i could right, be the complex value for the point P. So let's see what will happen when negative I is multiplied. When negative I is multiplied to negative 3 plus 4i, you get, 3i positive, right? Minus 4i squared, hence 4 plus 3i. You see what just happened? The values are not important. The signs are important here, guys. The thing is, whether I plug in 1 or 2 or 10 or 11, right? It's just that the real number here is negative. So when the negative real is multiplied by negative imaginary, together the product create a positive imaginary. And here, since, right, the imaginary was positive, when that is multiplied to negative I, since, it's double negative, I squared is still negative, right? It becomes positive, and I disappears. Hence, you'll be getting positive real too. So the point of this question is understanding what will happen to the signs for the real and the imaginary part of the value. And since they both become positive now, we don't know exactly where, but we do know for sure that this point will lie somewhere in the first quadrant. So you're looking for a point somewhere in the first quadrant. Well, you have to choose quadrant 1. Okay? So this two, guys, actually everything here we did here is quite important. This and the absolute value and having to look for the inverse of, right? Remember those and, don't forget them, please. Okay. So this is the end of complex value lecture. It's more of doing calculations. There's no confusing graphs here except for this simple point, right? Well, those are the types of questions that you might see. So just study them and remember them. And thank you for listening.